Welcome back, it's week 12 of Batteryman.
Having had an interest in electrics and electronics for years, I decided that it was time to take the step to become an electrician. Can you believe it? We're 3 months in now. Follow me on the journey in becoming an electrician. Let's get started with week 12 of becoming an electrician.
I started off this week by learning about critical path analysis, something I've never really heard of before. It's applicable to large projects. If you're just rewiring a house, it's easy to have all the steps in your head. But when it comes to much larger projects, there's a need to work out the order and to know how long things will take. The first step of critical path analysis is to list all the activities and the time required for each task. Then they're laid out with no two activities beginning or ending at the same two events. The advantage is that it's a nice, efficient way to show when different activities can start. Moving on to what I learned about with electrics this week. If we have a simple resistive circuit, we can measure the power by timesing the current squared by the resistance value. A simple resistive circuit could be a kettle. This would be referred to as active power. However, in a capacitive circuit, the capacitor charges and discharges as the voltage changes, meaning that the formula is no longer valid. We would measure this type of circuit as reactive power, and it's expressed as reactive voltamperes. An inductive circuit is similar, except the opposite way. The energy would be stored in the magnetic field of the inductor and then fed back to the circuit each cycle. In both of these types of circuit, the energy is effectively stored and not used, but for such a short amount of time. Most circuits are likely to have a mix of resistive, capacitive and inductive loads. This was all pretty new to me and takes a bit of time to suss out and get your head around it. I learned this week about power generation and how a large voltage is used by the national grid. This is to reduce the voltage drop, which ultimately would become heat. According to the information, there's nearly 5,000 miles of overhead and underground power lines linking power stations together and interconnected through the country. That's pretty impressive. The interconnection means that if there's an issue, power can be transmitted through other lines. A lot of the electricity is transmitted with overhead lines. The material gave me some reasons why this is chosen. These steel, cord, aluminium conductors.
So it's Sunday morning. I'm in the kitchen editing this video. I'm trying to edit these jumbled words to make it sound like a real sentence by going back and forth, cutting and chopping. I've been on this one sentence for like 5 minutes. Okay, who am I kidding? 15 minutes. And my wife turns to me and says,
"Don't you get bored of listening to yourself?"
Meanwhile, I'm trying to create a sentence that auto subtitles doesn't just turn around and dub, "Yeah, I don't know what this guy's on about."
Aluminium conductors are cheaper to install than digging up the ground to install an insulated and bunched conductors. Quite useful as well because air is a readily available insulator, so by just spacing the conductors apart you save yourself the cost of insulation. Air is also able to have a cooling effect for the conductors. I'd love to know how hot they get. Is it worse at peak times for the grid? It's once we get down to the voltages that are lower than 11 kV that we start to see a neutral conductor due to the change from a delta connection to a star connection within the transformer. An interesting difference between these two types of transformers is the delta load would draw 3 times the line current and 3 times as much power as a load connected to a star. This affects some type of motors. Induction motors connected with a star delta use a star for starting at reduced current and then switch to a delta connection. Again, there are calculations for working out line voltages, currents and phase voltages depending on the type of connection used. Interestingly, in a delta configuration, the neutral only carries the imbalance between the 3 phases, so there's a great need to ensure that the 3 phases are balanced. This is done by ensuring that loads are spread between the three phases. And when this is done, it's called a balance system. This spreading or balance continues into a single phase with our homes. For example, we spread the lights across the circuit with a ring on another. Diversity was mentioned. This considers the spreading of loads, taking into account how likely loads are to be active at the same time. I also looked at protective devices, which are designed to protect against earth faults and short circuits. These are the devices found in a consumer unit. Some factors that would be taken into account are the design current of the circuit or system, the disconnect time limitation, which will vary depending on the thermal trip, which tends to be slower, or a magnetic trip, the prospective short circuit current, which is the total path through the line, back to the transformer, and through the earth, and the rating of the protective device. It's no good using a 6 amp breaker for a ring main, is it? Plug in the kettle and it'll trip. A 30 amp or 32 amp would be far more applicable in this situation. In addition to mechanical breakers, there's a number of different fuses which are designed to break a wire by overheating it in the event of an overcurrent situation. Each one has its own BS standards. RCDs were mentioned, and I do wonder if this is one of the best things that's happened to the world of electrics in the last 50 years or so. They monitor the line and neutral and look for imbalances by creating a magnetic field which pulls a trip coil when a current is passed through an earth. As there's a mechanical element, they have a test switch which needs to be tested every 6 months. Modern consumer units accept a combined residual current circuit breaker with an overload protection, or an RCBO. The big advantage to this is it only affects the circuit that's at fault for all of the conditions that we mentioned above. These are a good upgrade. No doubt I'll be upgrading my fuse board at home once I'm qualified with these. Well, there it is. Another week of Battery Man. Next week I look at the studying styles and prepare for my first exam. Battery Man out.